So number 83 is a good example of a place where you would combine Newton's laws with the kinematics material from chapter 3. So this is 83 from A16. We know that we have an ice skater, and she coasts with no effort for 75 meters until she stops. So she's going to go from here to here, 75 meters, until she stops. And in terms of a force diagram, we know that there's weight, normal. They're going to be equal because there's no acceleration going in the x direction. And then we have friction going backwards. So the net force on her is equal to friction. Now the information provided is that we know her mass is 65 kilograms. We know, as I said, delta x, the distance she slows down over, is 75 meters. And the coefficient of friction, the kinetic coefficient of friction, is 0.10. And we need to find how fast was she going when she started to coast. So I'm looking for V1, and I know that V2 is 0. So when you think about the fact that you have V1, V2, and x, I need to find acceleration. I'm going to find that acceleration from from Newton's second law. So going back to my original equation that the net force is equal to friction, that means ma is going to equal mu times n, which is mu times mg. Notice that in theory, her mass will cancel out and not matter. It's unneeded information. So the acceleration is 0.1 times 9.8 meters per second squared, or just 0.98 meters per second squared. That's going to be a negative value. We should end up with a deceleration here, so I need to make sure that's negative. It would have come from back here, up top, that negative, that the net force is negative F. But it's important to know that that's negative if I have 75 meters be positive. Those are going to be opposite in sign. So now I'm ready to go and look at Chapter 3 material, kinematics, actually Chapter 2 material. I want to find V1. I'm going to use V2 squared, V1 squared, plus 2a delta x in this problem. V2 is 0, so V1 equals the root of negative 2a delta x. So V1 is negative 2 times negative negative 0.98, and the distance is 75 meters. And this is all under the square root. That was 75 meters. When I calculate, I get 38 meters per second squared. That seems very fast to me. That person is skating over 60 miles an hour. Let's double check that math. Yeah, I think hold on a second, guys. Yeah, I just redid this. I think I had an error in my calculation. I should get 12 meters per second, which is a lot more reasonable. Too bad you guys aren't here. We could have mistake cake. Oh well. And so that is number 83 from A16.